Hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says get smallest element in a matrix. Now here we are given a matrix of size n cross n where each row and column is sorted in non-descending order. Find kth smallest element in the matrix. So now matrix is in such a way where for each row is sorted and also the column is sorted. So if you have an element like 22, or I'll say if you have an element like 50, on the left hand side are all small, right hand side are all big or equal, upper side there are small for that column, and lower side are all big for that column. But upper right can be bigger than 50, or upper left that is ought to be smaller. That's the case. But upper right may or may not be bigger. In this case, let me take you. Here's no such a case like this, but it may or may not be bigger element. Like instead of 60, here can be 30, and the array would still be valid. But it cannot ensure that 40 is greater is 30. But anyways, that's not the question here. The question here is to find the third smallest element. So you see the first element is 16, next is 22, next is 27. That was so simple. It was within one column itself. But what if we have number like 7? You have 10, then 15, then 20, then 24, then 25, then 30. Now you're getting the drill. You're getting the drill that hey, it's not how you proceed, it's about the understanding that hey, my kth element can be anywhere. It is not always in first row, second row, third row, or it is not something like I can just a binary search upon these elements and then I can figure it out. You don't know. It's not a range, it's the number. It's a number where it is occurring, and they are asking us to have a complexity which is n log matrix of range. So this is the range. Basically they have made it more complex. They can have just mentioned that hey, it's a range what they are looking for. But yeah, so one thing which comes directly into our mind is hey, why cannot we go ahead and dump this matrix into an array? Obviously you can do that, but the size of that would be, space complexity of this would be n cross n, because matrix contains n cross n elements, and since it is n cross n, now you wanted to sort that element, and post sorting you need to figure out the kth smallest element. So it is O of n cross n multiplied by log n cross n. It is nothing but n log n, the time complexity, but n here is n cross n. So that would be direct dump brute force approach. So brute force approach, we don't want a brute force approach, so we can go ahead with something optimized approach 0, or next approach 1. We can say that hey, we might have something like existing data structure like heap or priority queue. One thing you can say that hey, within heap or priority queue I will fill up the elements, but that's not going to happen. It will go ahead and it will consume n cross n because you're iterating the entire array, and that's not what we want it to do. Or else you can just say that hey, I'll maintain the pointers, but maintaining the pointers would again take you to the time complexity, not more but obviously greater than or equal to the time complexity of n cross n. Means what I mean is you cannot go lesser than n cross n time complexity. So how can we deal with this? How to solve this optimally? Let's think of next approach. what we can do, we can have a binary search. So okay, binary search, now you're saying, but binary search has to have a range. What is your range? What is your left? What is your right? On what range shall I go ahead and search? So you see, we can exploit one of the feature here is the array sorted. The lowest element would be the first element 0 0, and the largest element would be n-1 n-1 within the array. So we have the range lowest, and this is the highest. We have the range. Now with this range, understand the middle, and once you got the middle, understand where, at what position is this middle. Now things are very clear, that we understood that hey, this middle is at 10th position, 7th position, or whatnot. Once you know, compare it with k, and once you are done comparing with k, you can just go ahead and understand that hey, I wanted to know it is greater than k, so I wanted to just focus on the left hand side, or I wanted to focus on the right hand side. It's a classic binary search problem. So without any further ado, let's get into the code, and I'm sure by the end you would be clear what we are going to implement. I'll take a, and initially it would be a of 0 0, and it would be a of length, so 8 of length, or I'll just go ahead and make it as a variable n-1 n-1, where n is nothing but final int n is equal to a dot length. Now while you see L is less than or equal to R, I want a mid, correct? A mid would be an item which I would be experimenting upon. Yeah, that's a correct number. I would be experimenting upon it. Mid is equal to L plus R minus L divided by 2. Now check out that hey, what position it is. Position is equal to get position. I'll get pos, I'll just say shorthand notation, with this a, within this a, and having mid. And if this position is less than k, I would search on the right hand side. So L is equal to mid plus 1, else R is equal to mid minus 1. Cool. And yeah, ultimately we need to return over here. I'll tell you what we need to return, right? But we need to return obviously something. Get position. So let's implement get position. Get position, what it does is nothing but understands at what position a element is if the numbers are not within matrix but would be within the array. So I'll tell you a number like hey, consider 22 within this example, at what position 22 is, and you would go ahead and definitely say that hey, 22 is at position 1 2, second position. And obviously I'll get the index. I don't want index, but again it will give me 22 would be at 0 1th index and second position. So what I'll do is int a, int x I'll say, and for I'll understand count to understand how many elements are previous to me. So if I got to know that how many elements are previous to me, I'll get to know the count of myself. That is the idea of this. I'll take each row from the matrix and I'll say that hey, int get me the first occurrence, and that will give me an index. I'll take the name of an index I, and I'll say first occurrence, give me the first occurrence of a, not a, but within the row for x. Cool. And I'll say the count plus is equal to I. But I don't want x, correct? I want x plus 1. Why? Because I'm counting x. So if I get x, that's not a problem. But I want x plus 1 so that previous to x plus 1, everything I should get. So that's an idea of this. And ultimately we get return CMD. That's the idea of this get position. And there is a first occurrence, which is very standard problem within binary search. You see, first occurrence means nothing but you have given an array A and integer x to find. You have left as 0 and right as a dot length minus 1, and you wanted to find out, hey, at what index I am. Pretty simple. And this would be left less than or equal to r. And as you know, how to implement first occurrence is very simple, that hey, check up per mid, which would be L plus R minus L divided by 2, and you are going to check with that, hey, if A of mid, if it's greater than your X, so I wanted to, I'm on a greater hand side, I wanted to go on the left hand side, so R is equal to mid minus 1. Else if I'll say A of mid is lesser than X, then I wanted to get more high, that means L is equal to mid plus 1. Else there can be a case that hey, mid minus 1 is greater than or equal to L, and A of mid minus 1 is equal to A of mid. That means it's not the first case which we are finding out. So in that case, I want R is equal to mid minus 1. Or else, if that is not a case, these are equal, but I don't have any matching element prior to me, hey, just go ahead and return mid. That's an idea. And if everything is not, sorry, this range breaks somewhere and we don't find our X anywhere, we just send L, which is the lower bound of X within the sorted array A. Lower bound of X within sorted array A, what does it mean? It means that, hey, all the elements, it would return the index of that element lesser than which, or on the left hand side of which, every element is lesser than X. So cool. We went ahead, we got a first occurrence. From first occurrence we got position, and from position we understood that hey, whether I wanted to proceed left or right. And in the end what I'll do is I will just return L because, sorry, A of L. Wait a minute, A of L or R? That's the question, right? Understand this, L or R. What does L signify and what does R signify? L signifies the lower bound. So do we want it to return that? Yes. Let's try to check this. Okay, int cannot be submitted. Oh yeah, sorry. Return L. Oh, sorry, because L and R both are the numbers itself. These are not the indexes. Within first occurrence, we were dealing with index, but here we were dealing with the number. I'll just quickly write it down over here. L and R are indices, and that can be go here. And whereas L and R are actual values we experiment with. Now let's try to submit this one to understand whether this code successfully passes or not. Okay. It just passed rest all the test cases. So this was an attempt. with binary search to solve this problem, and within the expected time complexity and the auxiliary space. The rest of the solution which I have found out these are not very appropriate. I think those were mostly just dumping an array, and those were just a brute force solution. The reason is quite simple. If you are quite short on time, just go ahead with heap approach. At least it's better than brute force, but again, it's an heap. But if you want most optimal solution and you're within an interview, just go ahead and implement this approach too, based on how much time it's remaining upon you within your bucket. And yeah, so this was a classic example of binary search and heap as well. So more of such videos, click the video on your right, and I'll see you in the next one.